Anybody heard of Hollywood Squares? I just feel like with this setup on Discord, we could do VFS squares.
Wait,
Zoom is easier for that.
Oh, probably.
wait. So what do we need to click on? I missed that. Sorry.
You don't want to see my video, you just want to see my screen share.
Ah, okay.
All right. Let's see if we can make some things go. Make sure we're all in the right place. We're all in the right place?
Yep, I think so. Except for Alvaro.
All right. Here's where we're going to go. We're going to try and get rid of some of the mysteries behind how we do some simple programming here. And we're going to do that by actually building some stuff. We usually start with kind of like what kind of assignment we're going to build. I'm going to get to that pretty early. And last night I kind of changed gears and changed the assignment. So Sean, the usual assignment that they do, and we're not doing that.
Yay, I have no idea what they're doing.
Hmm?
I have no idea what they're doing now.
Ah, that's good. That's good. You'll love it. It's awesome. But it's geared towards people who like writing story. So I think that'll work. How did the story class go last night?
That's pretty fun. Yeah, it was pretty fun.
Oh, it was awesome.
No
Amazing.
real work, right?
A lot of chatting.
Really? Really?
Get used to it. This programmer versus everyone else thing is going to pervade everything. So you can either be on the good side or the evil side.
It's still bullying.
You just have to do it from a project manager's perspective. If you walk through a game project and you extract one person at a time from your project of 5, which person is the person you can't get anything done without? Oh, the programmer. That's where that comes from.
If you don't
Okay.
have a story writer, you have nothing to program.
Yeah, no one gets to see it. It's not that it's not good stuff. Don't get me wrong. Love me a good story, love me good narrative. But if it doesn't make it to the screen, no one gets to see it.
I mean,
I'm just teasing.
Now, that brings me to the first point, which is, why the hell did you get into games in the first place? Uh-oh, screen bleed. Don't know how well this is going to work. There we go. A little bit better? Kinda. Part of the reason you got into games is because you want to tell cool stories, right? Part of the reason you got into games is because you wanted to play around with cool experiences. And when we talk about doing that, we need all sorts of components to make that a truly entertaining experience. We need great game design. We need a good story. And we need art to make it look great. But we need somebody to tie it all together and make it work as one. Otherwise, it's just a film. And film, while it's fabulous, is completely linear. It's stuff that's been done before, and the process is very well understood. The genres are clear and well defined. Games, on the other hand, give us the ability to explore a little bit. We have the ability to change genres. We have the ability to do things that have never been done before. In order to realize some of those dreams, it's helpful to know a little bit of programming. There's 2 real reasons I believe people should learn programming. One, there's a certain group of folks that will just latch onto it and love doing it, and it will turn into a career. For the rest of you, if you know how to do a little bit of programming, it's a whole lot easier to communicate with those that love to do it all day, every day. And both of those things are good, valid reasons if you're going to work in the game industry to know enough about programming to be able to converse in a reasonable sense and know what kind of things we need to put together. Now, how do I know all of this? Well, I'm going to reiterate the stuff Chris started with day one. The embarrassing slide that we all get, which is, hey, who am I? I've been doing this for a long time. I haven't always been doing this in games. I spent more than a decade working as a programmer and a project manager, building telecommunications systems, making people talk to each other. But my time working in games has been predominantly working as a producer and not a programmer. And when we work as a producer, we're building teams and building the plan to build products together. And that means multidiscipline. That means figuring out who's doing what, when, how much, how many, where is it all going to fit together. Now, our applications are typically very unique compared to other software applications. And so we have to bring a unique set of skills to the table. And when we start talking about unique set of skills, where we acquire that is with the influx of new people who have new experiences and new ideas. So given that you've probably done this about 5 times already, I'm going to ask you to keep it short as I go through and get you to do the brief intro thing one more time. I know your names. I can see them all sitting here. What I really like to see is where are you from and have you done any programming before?
I have a quick question. Do you want us to use webcams in your class, or is that not a
You
big
know,
deal
if
for
we're
you?
on Zoom, the webcams are great because I get to see faces. I'm going to try out the Discord thing today and see where it goes. I've got a good chunk of stuff to get through, and most of it is in that realm of here's a bunch of background stuff you need to do to get going. But as we go forward, we might change gears as we go. All
Cool.
right? So you don't need the webcam today, but it's helpful in the future. You know, it makes it more interactive when we have them. Otherwise, it's just me talking to the corner of my wall and hoping that there's something coming back on the other side. Make sense?
Yep, makes sense. But
Sure.
I have-
All right. So let's start with Amy. Just real
Hello,
quick,
Mally.
where are you from and have you done any programming before?
I'm from Nanaimo on Vancouver Island, and yes, I have. I did like a very basic HTML class when I was in university, and I also messed around with a bunch of Python coding for some visual novel projects I was doing for creative writing classes because I was tired of just doing basic creative writing.
Yay. See, that's exactly my point. The narrative part is critical, but if you can implement it yourself, you're a whole lot more valuable to yourself and others. So we'll bring some of that forward today because I think you're going to latch onto the project I'll give you.
Cool.
Chris?
Yep. Hello, my name is Chris, and I was originally from South Korea, but it's been 13 years that I lived since in Canada, and I do have a citizenship, so I'm a Canadian now. And
Yay.
in terms of programming, I did Python in the foundation program,
Yep.
and I have been trying to learn C# just by alone, but mostly like Unity C#. So yeah.
Right. Well, we're going to separate out C# from Unity here. I'm not going to do any Unity stuff in this class. All right?
Okay.
So
Yeah.
we're just good foundation of programming practices. Cyrus?
Hi, my name's Cyrus. I'm from Coquitlam, so it's pretty close to Vancouver. I took programming classes back in high school where we played with Visual Basic and then C#. And
Right? Jesus?
Yeah, so name's Jesus. Originally from Mexico, but basically been in Canada my whole life. I did do some work in Unity, but most of my knowledge comes from Blueprints and Unreal.
Okay. We'll forgive that for now. Jordan?
Hi, I'm Jordan. I'm living in Nanaimo now. I'm from North BC originally. And I've done a bit of HTML and CSS, but that's it.
Cool. Josh?
I'm Josh, and I am in White Rock right now, and that's where I'm from. Sorry, I'm having a hard time saying words. I'm very tired. I have
No
not done any
excuses,
programming.
Josh.
None at all. No programming whatsoever.
Cool.
So excited, a little terrified.
Don't be terrified. Sean will tell you. I make stuff easy. Karen?
Hey, you hear me?
Yep.
Okay. Well, I'm from Mexico. My name is Karen, obviously, and it's I came here to Vancouver to study writing first, and I just graduated like 2 weeks ago.
Glutton
And
for
I've done a
punishment.
little bit of prototyping in Unreal, but with blueprints.
Cool. Maple? No.
We can't hear
Maple,
you.
is
if
your
you're
mic off?
talking.
Maple, you there?
Can't hear you.
Her audio seems to be picking us up.
Yeah, she's echoing us.
Yeah.
So the input might be wrong.
Well, we're having technical difficulties. I can
Preach it,
totally
Maple.
relate. Hey, we had to hook up independent mics and cameras so that we would actually sound decent.
Can you hear me now?
Yeah.
No, no. Give me 1 second. There we go. Okay. Yeah, I'm Maple. I'm from Vancouver Island, living in Vancouver, and I've done zero programming.
Okay. Mason?
From Surrey, and I've done absolutely no programming.
Yay. Rem?
I'm Remy. I'm from Moncton, New Brunswick, and I have not done anything in this industry.
Hey. Sylvia?
Hi, my name is Sylvia. I'm from China. I've never done any programming before.
Good. Tomer?
Hi, my name is Tomer. I'm from Israel. I know a bit of C#, but yeah.
All right.
C#.
Okay. Full disclosure before I flip on to the next thing. While I've done lots and lots of programming and probably can program in about 10 or 12 different languages, C# is not my go-to day-to-day language. It's another tool in the toolbox. So one of the things I like to get people used to early on is the fact that as a programmer, you're a problem solver more than just a coder. And that means you're going to end up learning a ton of different things, and you're going to learn these different things because they're going to be like different tools in your toolbox. Different tools for different problems. Blueprinting, as much as we scoff at as more of scripting than actual programming, has a very useful capability when we're playing around in Unreal. And so we still use it extensively. When we're talking C#, there are some things that it does really, really well and really easy. It's a great language to learn because it gets you all of the programming concepts, albeit some of them are a little bit more difficult than I think they need to be. My go-to is JavaScript, as Sean can attest, and we can do some pretty cool, amazing things in JavaScript. But sometimes people find them a little bit more challenging than learning something like C#. People get really scared with C++. C++ is really just the grumpy old man version of C#. It's got a lot of things going for it, and you can control every aspect of your application or program, which is why it tends to be the favorite amongst old school programmers. It also tends to be the fastest by a long shot over any other programming language. And we'll get a little bit into how our programs are built, because I think you should have some idea of how things go together. So I'm going to change the stream up a little bit here. I'm going to flip slide decks, and hopefully my setups all work nicely. So we'll fade out and I'll tab around. Hello?
Hello? We can't see you.
I know you can't see me. I saw things just vaporize for a second and I got a little freaked out.
It's like the end of The Sopranos. If anybody gets that joke.
It's the, you know when you auto-minimize everything?
Yeah.
Yeah, well.
Oh.
Am I back?
Yes, you're back. Hello.
Yes.
Yep.
And it looks no different. Damn, I'm
Yeah.
good. Okay. So where we're going to start is we're going to start looking at kind of what do you need to know about software development. And the thing I'm working at here is I'm assuming that you know nothing and you haven't built anything before. I'm going to try and rewind a little bit and make sure you understand the basics of how your computer does what it does to compile and build applications without having to get into the gory, ugly details of an entire course on, you know, if any one of you had to go and talk at a conference and explain from the moment you hit power on your computer how Windows shows up, could you do it? Because one of the things we found was that there were a number of assumptions that we made as more senior programmers about how our machines work that we used in how we build programs. And as every new group of students comes in, we realize fewer and fewer of them had the complete background behind how this fits together. So I'm going to try and elaborate. If you have problems or questions, please just stop me and ask the question.
Okay.
Okay?
Yep.
All right. So, this is part of the sentiment I said earlier. You know, there's lots and lots of things you can do in media companies, and particularly in-game companies. But it's ultimately the programmers who put your application together at the end of the day. And that means that everything has to go through a programmer's hands. As much as we would like them to not go through a programmer's hands, they typically do. So, as people who are working on the programming side of things, companies generally place a higher value on programmers. Like it or not, they get paid more. They are held to a higher standard for sure, all right? They're very much expected to work at a higher, more professional level. They're not going to be the people that are going to be just joking around all the time with you. Sometimes they actually will turn you away and say, look, I need some quiet. I got to get things done. The other things go with that are that when they glue things together, often people put a lot of stress and pressure on them because they're relied upon to put the parts together that everyone else has made. You have to keep in mind, as a programmer on a team, your job is literally to make everyone else's stuff look better. Your job is to make the artist stuff look better. Your job is to make the narrative writer stuff better. Your job is to put everything in a way that everybody feels is going to look better than what they did on their own personal screen. With that comes a little bit of pressure. It also means that we kind of categorize and classify things because as human beings, we tend to like to do that. And we have no change in our attitude towards programmers that way. We all have kind of stereotypes of programmers. And that will probably be one of the first things that we'll end up breaking. Typically, the programmer types are also the ultra healthy, out in the world, doing lots of exercise, going for hikes, having fun with other people outside of games and outside of their computer. And part of it is that they're in front of the computer a fair bit. We also talk about programmers in terms of their capabilities. And when we talk about their capabilities, we're generally thinking about how qualified are they to do the work. We have some words that we use you'll hear tossed around a little bit. Now, some of these words we like, and some of these words we don't like. There's definitely a experience level that goes with these too. So typically people start out as some sort of enthusiast where they kind of wish they knew how to program, but they don't really know where to start or what to do or what to look for. After they start some self-training, we generally refer to them as hackers. And that doesn't mean somebody who's getting into illicit systems. That means somebody who doesn't really know what they're doing, but manages to make a few things work. And so we kind of scoff at these folks, but really, as long as they're showing the right attitude towards continual learning, they're going to be just fine. The lowest level of programmer that most people will hire is what we call a coder. And we don't actually expect them to design anything or solve any big problems. We kind of chuck stuff over the wall and say, hey, I figured out a solution. You go write all the low-level grunt code that actually makes my solution happen. We try and evolve folks. We make those coders into programmers. And I've got it highlighted because I'm hoping that by the end of this course, you guys are feeling a little bit like you're a programmer, at least in name, so that you can converse with other programmers and understand what the hell they're talking about without it being complete gibberish. Developers are kind of guys that do major problem-solving efforts. They will often have a programmer working with them or for them, and they will be the guys responsible for entire areas of an application. Leads is a very loaded four-letter word. So make sure that in your experience here, I would stay away from that word. The reason it's kind of loaded, particularly in game development, is there's about 10 different major areas in every game that we have to build. Everything from AI to rendering, networking, save load, user interface, those kinds of areas. And a lead programmer is typically a programmer who's completed an entire game cycle and shipped a game in each game area. And that's typically guys who are well over 10 years experience. So if you come out of school and you say you were the lead programmer on your project, they laugh at you and they don't give you the kind of credibility you need to be able to get into the workplace and start absorbing what they're doing. We get more senior beyond that into architects who start figuring out how entire applications fit together, what are all the pieces and sub-pieces, subsystems, and how do they interact with each other. And finally, we get to a technical director who's kind of got one foot on the technical side and one foot on the management side, and they're trying to organize their programming team around how do they solve the particular problem in front of them. Now, I've hinted at something that we're going to do a lot of, and that is we're going to take complex problems that we have, and we're going to try and break them down into very much smaller problems that we can manage and help. Okay? All right. So let me go back here. So when we do this, we got to assume that as people who are going to be doing the programming, there's a few things we need to be able to exude or show other folks. The first one is a professional attitude, and that involves a couple of things. The first one is, how does your attitude work? And what's your attitude towards solving the problem? You need the positive person who's going to be a problem solver someone who's got good work habits, someone who has the techniques and the know-how, and someone who has credibility. And that's kind of the toughest part, is credibility. You should recognize that whenever you go into a new situation with new people, whether it's school, whether it's work, whether it's a new job, you effectively jump in with zero credibility. And until you have your credibility built up, you don't really get to have a say in how anything works. That's kind of the challenge that people have when they first jump in. You might have all sorts of technical skill, you might have all sorts of great ideas and great attitude, but until you have the credibility with the people you're working with, they won't believe a thing you have. All right, so let's get into some of that, because some of this is going to carry over into how we design and build our software. And this is the part I like to talk about, pros versus Joes, right? And in case, has anyone not heard the term pros versus Joes?
Me.
Yeah?
Yeah.
Okay, let's see if I can illustrate it. This is a pro. Agreed?
Yep.
Yep.
Yep. That is
This is Joe.
Okay.
Okay, so Joes typically sit on the couch. They got the big gulp in front of them. They'll tell you what's wrong about every game that's out there, even though they have no clue how to build them. They have no clue about the design choices that had to be made. They have no clue about the technical choices that had to be made to make certain things happen. They're just critical of everything. Pros, on the other hand, take a look at the entire application that they're building and try and figure out, hey, what's the best way I can solve this problem with the tools I have? Do I need to get help? Do I need more tools? Do I just need to work the problem from a different angle? It's all about creative lateral thinking and solving problems. So we're going to strive here to be a pro. Some of the things that we need to make sure we don't take away from our credibility by blurting out crazy ass things without any technical foundation or background. If you don't know how to do something, we got to figure out how to do it. And this will be one of the more painful things that people end up dealing with. When you start working as a programmer with a group of people, you will find very quickly that everybody comes to you for answers like you know everything. So first of all, you don't have to explain that you know everything. I don't know that, let me look it up. Second, you're going to have to look a lot of stuff up. There's going to be a lot of manuals, a lot of reading, a lot of going through separate, different pieces, asking people. The third part, show me, don't tell me. Don't tell me how something should work, just build one and show it to me. Make it work in front of me. All of these things will build your credibility. When you get into the working environment, that ability to figure things out, show me, not tell me, are the things that build credibility. And once you build up enough credibility, you get what I call your credibility bucket. Now, once you get your credibility bucket and you start accumulating credibility, you start filling up your bucket. You don't get to make suggestions on how big teams work or how medium-sized teams work until your credibility bucket is full and overflowing, at which point people listen to you. Think of it as currency, okay? Your job is to figure out how to fill your credibility bucket by helping others, by providing solutions, by showing people instead of just telling people, and by trying to figure out how you can help someone around you. It's also kind of the definition of teamwork, right? And teamwork really is about how games that are really quality games get built. There's a few things we want to pay attention to. Time estimation is one of them. Everybody is horrible at time estimation. Don't feel like you're left out because you're not good at time estimation. I worked as a project manager for 12 years. Nobody's good at time estimation. I had to keep a spreadsheet with multipliers for everybody on my team. Someone would say, hey, I think that's going to take 3 days. I'd go look up in their spreadsheet and go, yep, times 3. It's going to take 9 days. okay? Everybody has a perception of how quickly they work, and programmers are the worst for being super optimistic. So instead of, hey, I think it's going to take 3 days, what I want you to be thinking about is, the last time I did this, it took 5 days. And I mean 5 days from the time I started working on it till the time I took my hands off and I never touched it again. Till it was bug-free, 100% working, showed exactly the way I wanted it, and I never had to come back to it again. Second part in there is going to be about not being too territorial. Teams make best products. And so when we're talking about teams that make really good products, what we're really talking about is people sharing what they're doing. Now, you're going to hear this from a lot of instructors about do your own work, don't plagiarize this, don't plagiarize that, don't copy other people's work, don't copy off the internet. I haven't had a lot of issues with people copying off the internet in my classes, usually because my assignments are completely different from anything you will ever find on the internet. Usually. I don't know whether Sean can. Have you ever found one that's similar, Sean?
Not yet, no.
Not yet, no. But it's okay to look at other people's code. It's okay to ask people in your class for help. It's okay to ask Sean for help. It's okay to bug me for help, all right? No one's expected to just understand this moment one. Sometimes it will take weeks before it starts to sink in. That's normal. So get your mind set for the idea that you're going to do some stuff. It's probably not going to work the first time. You're not going to understand why it doesn't work. You're going to puzzle it out for a little bit. The skill here is in learning how long it takes you to reach out for additional help. Did you try Googling it yourself? Do you know what to Google? Have you got an example of something that does work? And once you've tried all those things and you still can't get going, have you tried your classmates? Have you tried Sean? Have you tried to figure it out on your own? If that's still not working, then you start reaching up the ladder. All right? Last thing has to do with games in general. Unlike other software, game projects typically are never finished. They're not complete. They're kind of abandoned, really. When you get to the end of a project, you'll notice that there are tons of things left to fix, modify, change, complete. And game products are probably amongst the worst for this. Because we're not mission critical software, because we're not, working with things that people rely on for their lives, then games tend to be a little bit looser in terms of how they operate. I'll give you an example. Before I ever worked in games, I worked in the telecom business, and we used to build telephone switches, the physical hardware, so that when you pick up your phone and you dial a number, it actually connects you to another number. And they're driven by software internally. And I had a boss who was very clear about the fact that testing was not just mandatory, but had to be redundant and done by multiple people, because our software that ran in switches had to make sure that there was never a time when someone dialed 911 and it didn't work. That's a level of must-work perfection that we just don't have in games. A typical game will ship a certain percentage of the bugs it finds. Does anybody have an idea what percentage of the bugs we allow to be shipped through in a game?
Does it change if you're Bethesda?
Not so much.
It's 10%.
12? Yeah.
I don't know, 5%?
A lot.
The average game in industry ships with 18% of the bugs unfixed. As designed.
Wow.
Right. Typical game. I have worked on games that have shipped as many as 20% of the bugs. Now, part of that has to do with the nature of bugs. And when you start talking QA, we get into categorizing and classifying bugs in terms of priority and severity. And there are certain things when you're getting near the end of your project that is, I do this and the game crashed. I'm going to fix that one. There are other things where I did this and the tree looks like the wrong color green as I went by at 30 miles an hour. Yeah, I'm not shipping that, or I'm not fixing that, right? So not all things or problems are created equal. Now, what we want to do when we're building our applications is make sure that we pay attention to all of these things. And the easiest way to do this is by keeping yourself a little notebook. So one of the good habits to get into early on is to keep notes on what you're doing. Little scribbles, doesn't matter. You're going to put them probably in ink. Most engineers will find this as an engineering notebook. You're going to put the name and date on every page, and you're going to just do your doodles and scribbles right there. And there's a couple reasons for this. First one, time estimation. You can write down when you start working on something, and you can flip back through your notebook and find out when you finished it. The second is you can make lists of things that are not finished or things you need to do in the future. It makes for a good checklist kind of system. The third part has to do more with the business of games. If you get used to doing this as a habit early, that when you get into working with a game company, what you will find is that there are certain financial things that they can do. They get tax credits and incentives for doing research and development. But they only can get the tax credits and research if they can prove that they were actually developing the things they say they were or researching the things they say they were. And how do they prove that? Well, they collect up all your notebooks and they summarize what's in them. That's where you have to be not territorial. It's not about criticizing your handwriting. It's not about critiquing what you do. It's about having a permanent record that proved that you came up with that idea first, you built that thing first, you did the research and development on how that thing should work. Scribble down anything you need to know to remind you of how to put those things together. This could be research on how to do pathfinding for your enemy AIs, or specific notes on how to write certain chunks of code that were really, really problematic, and you found an article online that shows you how to do that one thing. All of this stuff can go in that notebook. At this point, I'm just telling you, start writing this stuff down. It makes for good habits, and those habits will come back and help you later. A few notes on the estimation time of thing. I said nobody's very good at it. The only way you get good at it is by doing it. And one of the things you need to keep in mind is that as you start writing some programs and some software, you will find that there's a nice, clean, easy way to do it, and there's a quick and dirty way to do it. The quick and dirty way will come back to haunt you. So do the things kind of the right way, if you can, every time. In game industry, you probably will never get the chance to go back and do it a second time. Someone says, hey, how long is that going to take? You give them an estimate. You get within a day of that estimate. They're pretty happy. You're pretty happy. It kind of works. But if you had to hack it together, and it's very what we call brittle, in other words, if anyone pushes it a little bit too hard with testing, it's going to break. You got to go back and do it again. That's wasted time and wasted effort. So try and do things right the first time. Try not to be that person that thinks they're saving time and effort by doing things the short way, only to have to do it twice. Because the doing it twice always takes longer. Now, I'm going to ask you guys time and time again to write quality code. Not everybody understands completely what that is. So I'm going to try and elaborate a little bit. The first thing is almost all companies out there will ask you to put their name on the software that you write. And specifically, I ask you to put a copyright in every file you write. The reason I ask you to put a copyright is that software, surprisingly enough, is copyrighted as a literary work. It is, to the law's eyes, no different than Harry Potter in terms of copyright protection. So, in order to own it, you need to put a copyright notice in it. It's a single line. I'll show you how to do it. It's one comment. If you don't put a copyright in there, you don't own it. Now, that's not such a big deal right now, but if you do come up with something really brilliant, and you don't put your name on it, and you don't put a copyright in it, and I think it's really cool, I might just put my name or copyright on it and own it. So if you want to own your stuff, make sure it's copyrighted in your name. The second part there is put comments in your code. And you'll hear this from every programming instructor ever. Comment your code, comment your code. What they rarely tell you is what to put in the comments. And we're going to give you the hint in that, and I'm going to reiterate it time and time again. Write your comments to yourself. Write your comments to your future self. I guarantee you the person who's going to come back to your code more often than not is you. And you're going to come back to it 6 months from now, and you're going to shake your head. You might even cry a little bit when you look at what you've done. And you might go, oh, what was I thinking? And so the most helpful thing you can do is write in your comments why you did what you did. What I don't want you to do is write a comment for every line of code you make. And again, I'll come back to this. Don't write a comment for every line of code you make. Do not paraphrase your code. I can read lots of different programming languages. I do not need you to tell me what an if statement does or what a variable assignment does. I can read the code and figure that out. What I need to know is why did you do it? And when you write your comments, if you write them to yourself, your future self, you give yourself the opportunity to, when you come back to it, know why you did it. I shouldn't have to say it. Put your name and date on everything. It's something you kind of learn in grade 3, but surprisingly, we see a lot of stuff where people forget this entire simple process, name and date. When it comes to programming as well, I'm going to ask you to give up elaborate, elegant solutions for simplicity and maintainability. And this is just the old guy programmer in me. More often, you're going to have to come back to code to fix bugs or problems that are in it. And when you come back to fix those problems, the more intricate, delicate, elegant the code is, the more fancy language structures that the programmer used, the longer it takes you to figure out what that programmer did and fix their problems. If you focus on make it work, make it simple, keep it straightforward, it will be much, much easier 6 months from now to go fix what was done there. Now, I can encapsulate this in all sorts of different ways. We can deal with, the whole, how do I make maintainable code? How do I automate things so they always happen the same way every time? Focus on consistency. But there's a quote that I found on the internet that just sums it up so perfectly, I have to share it. This Martin Golding quote is just spot on. Clear?
Yeah.
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 That makes a lot of sense.
All right. The other thing I have to elaborate on a little bit is expectations. And I don't mean expectations in the class. I mean expectations as a programmer. You see, unlike other disciplines, the programming discipline isn't a nice, smooth, straight line like the art is on the chart here. Programming tasks don't tend to just fall into place in a perfect linear order. It takes time. If you have a week to work on a programming problem, start early, because it's inevitable that as you start working on it, you get into a place where you get stuck, and you get stuck for a long time. You kind of go through a cycle, and the cycle mentally feels like this. It starts off early with the, okay, I think I get this. And you start writing code and things start working. And then you run into one of those roadblocks. That's that first little corner on the step chart there. And as you run into that first roadblock, you're going to turn around and you're going to be like, oh my God, I have no idea what's going on here. I don't know why this isn't working. It's a complete mystery to me. I don't understand what's going on. And you start banging your head on the table. After a few days of doing this, you stumble across an article that has something similar, and you kind of clue into one of the concepts that you were missing, and you go back and you look at your code and you see that one letter was spelt wrong and it was 2 separate variables, not one. And you're like, oh my God, I'm an idiot. I totally understand what's going on here now. And you take that giant leap straight up, And you go back to that elated, I am a genius. I know exactly what I'm doing. This thing is awesome. I can make all sorts of stuff happen. And you carry along the next little flat line until you run into the next roadblock. At which point, you're like, oh my God, I have no idea what's going on here. I don't know why it's not working. You will get into this cycle. The other thing you need to be aware of when you get into this cycle is when things are working, you will be subject to one more itis. And I don't know if any of you guys have found this personality trait amongst yourselves. Probably the answer is yes, otherwise you wouldn't be here in game design. One of the traits that we all have is that once things start working, you kind of get something on the screen, you get that instant gratification of it working, and you're like, yeah, that's cool. Hey, let's do another one like that. Hey, just one more fix, one more fix. I'll go for dinner in a couple minutes, just another fix. And if you started at 4 and you started doing these one more fixes, sometime around 7 o'clock at night, you pick your head up and you go, oh, it's 7. I should have had dinner. What happened? And then you kind of like, well, just one more little fix. I'll just fix this one thing before I move on. I'll go get some dinner. And you pick your head up again, it's 9:30 at night. You forgot to eat completely. And then you're like, yeah, okay, I'm a little hungry, but I got some chips here beside me. I'll just have a snack. And then things are working, so I don't want to stop. And you just keep making one more fix, one more fix, one more fix. Next thing you know, you pick your head up, it's 11 o'clock. Oh, crap, I got class tomorrow. But it's working. But well, it's not quite perfect. Let me do one more little fix. The next thing you know, it's 1:30 in the morning, and you're overly tired, and you're wondering, hey, how come I'm tired all the time and staying up late? And then I'm going to be telling instructors that I'm sorry I'm so late. I'm sorry I'm tired. I stayed up late last night working on your assignment. Be aware of it. Manage your time. Start early on things. Give yourselves cutoffs. Don't forget to eat. Get out of your chair every hour or two. When you're working with programming stuff, recognize the situation that's going to give you the best success. Statistically speaking, when we talk to lots of programmers, the thing they will be consistent about is that it takes them about 15 to 20 minutes to wrap their heads around the code that they're working on and start to be able to make progress. At which point, typically the longest session you can go for is about 2 to 3 hours before you start losing productivity. And every time you get interrupted, it will cost you 15 minutes to bring your head out of that zone and 15 minutes to get your head back in that zone. So, in order to do effective programming, what you want is a block of 3 hours to 4 hours of time, and you want silence. Putting your headphones on and listening to music requires you to be so well versed in the programming language and constructs that you're doing that you don't need to concentrate on them. This is a high intensity concentration you're going to need to make it work. I just want to set you up with those expectations early so that if it's easier than that, you're like, Scott's just making it sound scary, but it's not. All right? Expect the roadblocks, expect a little bit of frustration, push through the frustration. Usually gamers make good programmers because gamers understand what it's like to try something, get killed, have to start over, try something, get killed, start over, try something, get killed, start over. So we're going to embrace that.
Out of curiosity, how long was the longest roadblock that you had to face?
For me?
Yeah, for you. Yeah.
Think in terms of weeks.
Oh.
Here's the other trick behind that. That little step chart that I've got on the screen for you right now.
Yes.
That doesn't ever stop no matter how much experience you have. What happens is every time you climb one of those big steep hills, you learn something new. Every time you learn something new, you start to imagine ways you could use that new thing to do bigger and better things. So you start biting off bigger, better, harder, more challenging things to do. I'll give you the exact example that we're going to run into shortly. Sean and I have a class in term 3 So after just 4 months of programming on the PG side, where they're going to build an 8-player multiplayer online game, including the client and the server, and they're going to do it all in 7 weeks. Sound like fun?
Okay, I mean, it sounds fun, but the building would be complicated
Yeah.
because of the multiplayer.
So it sounds really scary, but when you start breaking the problem down and you have the background and the skills, you start to take on bigger projects. But you still run into these roadblocks. It's just the roadblocks are more complicated. And so sometimes they take longer to solve. Right? A real life one, going way back. One of the problems we encountered as a team with the very first SSX game is that we had 4 megs of RAM, and we had tracks we were building in a snowboarding game that were in the order of 16 megs. So what do you do when you got to fit the game code, the audio, the character models, the rigs, the animation data, and the tracks in 4 megs of RAM, and the track takes 16?
We gotta reduce it, but
How?
yeah, that's the point.
Okay. And the solution came from a technical guy combined with an art guy who went into Maya and said, hey, you know, if we use Bezier surfaces, and I'm not going to get into what they are, but it's using splines in a way. If we use Bezier surfaces, we can cut the volume of data we're keeping down into 1/10 of what it was. The only challenge is we have to go talk to the rendering guys because they have to figure out how to take those Bezier surfaces and turn them back into polygons. Can they do that live at runtime? So that one took weeks to solve. So you will never run out of these problems. Sometimes the most interesting stuff you will ever do will be born out of some of these problems that cause huge roadblocks. What I want you to picture in your head, though, is that unlike building art, it doesn't go in a linear fashion. It's probably closer to the folks who are used to writing stories and narrative, right? Narrative stuff rarely goes in a perfectly straight linear line. Your productivity on day 1 is not the same as your productivity on day 10. It's not the same as your productivity on day 35. You will be more productive, but you will take on more challenging projects which potentially slow you down more. Whereas art, you're as productive on day 1 as you are on day 100. There is a rate at which you can crank out art. It's just constant. So we watch out for that. Now, fortunately, Sean was in there the other day, and he was helping you with some of this stuff. We have some tools of the trade to make our lives easier, and part of this is based on programmers are inherently lazy. So if you take the lazy man's approach to most things, you're probably doing it right. By lazy, what I mean is there's a lot of things we need to do, and we want to do them the easiest way possible. And so whenever we run into a problem that seems like there's a challenging, complex solution, we typically will write a tool to help us write other tools. You built 2 of them, or you installed 2 of them the other day. First is source control. Let me be clear. The USB stick that you have is the most unreliable thing you will ever use. It is the short-term, get something from A to B when there's no other way. It's slow, it's nasty, and just like a game design team that had their final project on a USB stick and accidentally dropped it down the drain a day before their pitch and play, you do not want to rely on a USB stick for anything. They also get corrupted really easily if you don't eject them properly out of computers. The second thing is that on our environment, both locally and on VFS's schools, you have a number of network drives and resources. And these are typically where you want to place things that you want to be permanent. However, there are some caveats there. The first one is don't put anything in your documents folder. there are many industry guys and even more instructors that just simply write a 0 on any assignment that has documents in the path of the file names. It's just unprofessional to do. And the reason is that no one's documents folder is the same. It's not in the same place, it's not the same location. Typically, if you have a file listed there, it's often referenced from that location, which means it only works on your machine, which is the worst excuse ever. It only works on my machine. I can't ship your machine to 1 million people. The other thing is, don't use the H drive. The H drive is just a drive letter that our IT guys have concocted to attach to our network drive when you're logged in through the remote desktop through Teradici to our computers at school. It doesn't exist outside school. And it may not be mapped to the same drive letter in every different computer that you're on. So again, it's inconsistent. You don't know where it's going to go or where it's going to be. Where do you put things? Well, if you've downloaded it from the internet, you don't put it anywhere. You just leave it on your local computer. If it's downloaded from the internet, anyone else can download it from the internet. If it's required, write a little README file to tell you all the things that you require. If it's something you created, original source material, whether it's story, text, art, or code, the original source material goes in the source control system, where it manages every version that you've ever done, just like a giant save game system. Generate things automatically. You want consistency above all else. So when we build our applications, we want to regenerate our documentation automatically. We want to rebuild our application the same way all the time. So we tend to write tools and scripts to automate this process. Right? Now, all of these things together can be summed up in 2 simple statements that as the programming part of any team, you want to be aware of. And these 2 simple statements are really questions. And they're questions that we call the razors, or the questions we ask about any piece of software. And the questions are we building the right thing? Are we building the thing right? So what we're trying to do here is figure out how exactly should we be building our application. And depending on whether or not we're building the right thing, are we using the right tools, the right techniques, the right capabilities to turn around and construct our application. All right, I've done enough preaching. We're going to take a short break because you've been sitting at this a while. Let's go for 10 minutes. It's enough time to get your coffee. So I'll come back at 10:10 and I'll probably just leave the stream running here. I'm not quite sure. But I'll flip the cameras off. You guys can go grab some coffee. I know I will. And when we come back, we'll start getting into actual C# stuff. This is just the stuff we need to get out of the way. All right? All right, guys.
Yep.
All right.